Today we're diving deep into AWS DNS and domain management, one of the most critical topics for your AWS certification journey. As someone who'd worked with DNS for over a decade, I can tell you that Route 53 is truly revolutionary. Before Cloud DNS service, managing global DNS infrastructure was a nightmare of server maintenance and complex configuration. What we'll cover today isn't just theory, these are real world scenarios I've implemented for Fortune 500 companies. We'll start with the fundamentals and build up to complex hybrid architecture. By the end of this presentation, you'll understand not just how to configure Route 53, but why certain design decisions matter. Here we're looking at the Route 53 DNS service, its domain registration, global DNS network, and traffic policies and health checks. Let me walk you through what actually happens when you type a domain name in your browser. This 8-step process happens in milliseconds, but understanding it is crucial for troubleshooting. In my experience, 80% of websites' performance issues come down to DNS configuration problems. When a client makes a request, it first checks to see if the local resolver, usually your ISP DNS server or something like Google DNS. The recursive lookup starts with root servers. There are only 13 of these worldwide. Then it moves to top level domain. The top level domain, for example, .com, .org, etc. It reaches the authoritative server where your actual DNS records live. Notice that the caching at each level, this is why there's caching at each level. This is why TTL values are so important. Set them too low and you'll generate unnecessary DNS traffic. Too high, updates take forever to propagate. DNS security adds a cryptographic validation to prevent DNS poisoning attacks. I always recommend enabling it for production domains. These are the building blocks of DNS. Let me share some real world insight about each type that you won't find in the documentation. A records are your bread and butter. They map domain names to IPv4 addresses. But here's a pro tip. Use Route 53 alias records instead of A records when pointing to AWS resources. They are free and automatically update when underlying IPs changes. The CNAME record creates aliases, but they have limitations. You can't create a CNAME for the root domain. That's why we need alias records. I've seen companies struggle with this. The MX record for email are critical to get right. The priority is backward. Lower number have higher priority. I always start with 10 primary, 10 for primary and 20 for backup. The TXT records are increasingly important for security. SPF records prevent email spoofing. DKIM provides email authentication and domain verification. So SPF allows domain owners to specify which mail servers are authorized to send an email, and DKIM uses cryptographic signatures to verify that an email was not altered and comes from an authorized sender. Okay, the diagram shows the complete Route 53 ecosystems. What makes Route 53 special is how all these components work together seamlessly. Hosted zones are containers for your DNS records. Public zones Uh, Public zones respond to internet queries. Private hosted zones uh, respond to private DNS queries. Health checks are Route 53 secret weapon. They continuously monitor your endpoints from multiple global locations. When an endpoint fails, traffic automatically routes away. No manual intervention is needed. Traffic policies provide a visual editor for complex routing scenarios. Instead of managing dozens of individual records, you can create reusable policies that implement your entire traffic management strategy. The resolver service bridges on premises and AWS DNS. This was a game changer for hybrid architecture. Before this, company had to maintain complex DNS forwarding. So here is Route 53 where it really shines. These routing policies solve real business problems. Simple routing is just basic DNS, one name, one IP, but weighted routing is perfect for A/B testing. Latency based routing is magical for global applications. Route 53 continuously measures latency from users to your endpoints and automatically routes to the fastest one. Um, your European users would hit Ireland servers, aliases, and Asian, you would hit the Singapore. Failover routing creates active passive configurations. When your primary site fails health check, traffic instantly switches to backup. I've seen this prevent major outages during data center failures. Geolocation routing enforces compliance requirements. Some company must serve EU users from EU servers due to data sovereignty laws. This is the AWS CLI command I run first when setting up DNS for any domain. The caller reference is crucial. It prevents duplicate requests if your command times out. The timestamp trick ensures a uniqueness. In production environment, I recommend using more descriptive references like initial setup. When you create a hosted zone, AWS automatically generates 4 name servers. You must configure these with your domain registrar or your DNS won't work. This is the most common mistake I see. The comment field seems optional, but trust me, 6 months later, when you have dozens of hosted zones, you'll thank yourself for putting a real description. So what returns after running this command? AWS returns the name server list. Copy these immediately to your domain registrar DNS settings. Private hosted zones are incredibly powerful for internal service discovery. Instead of hard coding IP addresses, your applications can use friendly DNS names that work only within your VPC. The key difference here is the VPC association. This zone will respond to queries from within that specific VPC. I often create private zones for each environment: dev, internal company.com, staging, internal company.com. This prevents accidental cross-environment connections. You can associate additional VPC later with the associate VPC with hosted zone. This is common when you have multiple VPCs that need to share internal services. A security note: private zones don't work over VPN or direct connect by default. You need Route 53 resolver. Health checks are what separate Route 53 from basic DNS services. This example creates an HTTP health check. that monitors your API endpoints. Here it's reference. And will request interval every 30 seconds, and failure threshold of 3. So if three checks fail, then it's gonna fail over. The failure threshold is with 3 failures over 30 seconds, your endpoint is marked unhealthy after 90 seconds. For critical services, I sometimes use 10 seconds interval with a threshold of 2. Route 53 perform health check from multiple global locations, typically 15 to 18 checkers. Your endpoint is only marked unhealthy if the majority fail. This presents false positive from network hiccups. String matching. Health check are incredibly useful. You can check specific content like status OK in your response. This catches scenarios where your web server responds but your application is actually broken. CloudWatch is an integration automatically creates metric and alarms. Set up SNS notification to get immediate alert when points fail. This is my favorite Route 53 feature for deployment strategies. Instead of risky big bang releases, you can gradually shift traffic to new you can the set identifier must be unique across all records with the same name and type. I use descriptive names like V2 Canary 10% to make purpose obvious. Weights are relative, not percentage. If you have records with weights 70 and 30, that's 70% and 30% respectively. But if you add a third record with weight of 10, it becomes 64, 27%. It basically becomes weighted based on the total, the number divided by the total. The lower TTL is crucial. Here's 60 seconds. Is crucial for weighted routing. You want DNS caches to refresh quickly so traffic distribution changes take effect rapidly. I typically use 60 seconds or less. Always associate health check with weighted record. So here, health check is what we had created previously. The health check here. Okay, and then always associate health check with weighted record. If one version fails, traffic automatically goes to healthy endpoints. Latency-based routing is phenomenal for global applications. Route 53 maintains a database of latency measurement from users worldwide to all AWS regions. The magic happens automatically. A user in Tokyo gets routed to your app North 1 instance, Northeast instance, while a user in London gets your EU West 1 instance. No configuration needed beyond specifying the regions. This isn't geolocation routing, it's purely based on network latency. Sometimes users get surprising results, like East Coast US users routing to Europe if their path is faster due to internet routing quirks. I always deploy identical infrastructure in multiple regions and use latency-based routing to let Route 53 optimize the user experience automatically. Remember to set cross-region replications for your data if you're using this approach with stateful applications. Here we're creating a record. Well, for a record, and then the TTL is here, and the health check is here. Failover routing, active passive architecture. The primary record must have a health check. This is how Route 53 knows. When to failover. When the primary endpoint fails its health check, Route 53 automatically returns the secondary record. This happens within minutes globally due to DNS caching behavior. I recommend the health check for secondary records too. If both primary and secondary fail, Route 53 will return both records and let the client try both. Without secondary health check, you might route to a failed backup. For critical systems, I often combine failover with other routing policies. You can have weighted distribution between multiple primaries with failover to a standby. The key insight here, DNS-based failover is fast but not instant. For sub-second failover requirements, you need application-level solutions like load balancer health checks. This diagram shows a complete hybrid DNS setup, the holy grail for enterprise AWS migrations. It allows seamless name resolution between on-premises and AWS. The inbound endpoint here from corporate DNS, the inbound endpoint lets on-premises servers query AWS private hosted zones. Your corporate applications can reach database.aws.company.com, for example, without knowing it's actually in AWS. The outbound endpoint works in reverse. AWS resources can resolve on-premise DNS. This is crucial during migration when some services remain on-premise. Conditional forwarding rules determine which domains get forwarded where. Queries for corp.company.com go to on-premise DNS, while aws.company.com go to on-premise. Conditional forwarding rules determine which domains get forwarded where. Queries for corp.company.com go to on-premise DNS, while aws.company.com and Route 53. The security aspect is crucial. All DNS traffic flows over your VPN direct connection. Here's how we build that hybrid architecture. Start with the inbound result endpoint. This creates IP addresses in your VPC that on-premises servers can query. You need endpoints in at least 2 available zones for high availability. I learned this the hard way when AZ failure took down DNS resolution for an entire data center. The security group must allow inbound DNS traffic on port 53. Both TCP and UDP. Don't forget TCP. Large DNS responses required. Those IP addresses become your DNS servers in on-premise configuration. Here's like subnet ID, the IP you selected, and then other subnet ID. Those IP addresses become your DNS servers in on-premises configuration. Point your DHCP servers to these. DNS servers to these can suddenly all corporate machines can resolve AWS private DNS. The billing is per endpoint per hour, so plan your architecture carefully. Each endpoint costs about $90 per month, but one pair can serve multiple VPCs. It's the outbound endpoint enables AWS resources to query on-premise DNS. This is essential when you have hybrid applications that need to communicate with on-premises services. Unlike inbound endpoints, you don't typically specify IP addresses for outbound endpoints. AWS manages the IPs automatically within your specific subnet. Um, Security groups for outbound endpoints need to allow outbound connections to your on-premise DNS. Make sure your firewall allows the connection back as well. I always create outbound endpoints in the same subnet as inbound endpoints for consistency and easier troubleshooting. Remember, you can share resolver endpoints across multiple VPC using Resource Access Manager. This saves costs when you have many VPCs in the same region. Conditional forwarding rule resolver rules are where the magic happens. This rule tells Route 53 to forward all queries for corp.company.com to your on-premise server. The domain name support wildcard. So the domain name support wildcards using corp.domain.com forwards queries for any subdomain like server1.corp.company.com and so on. We can specify up to 6 target IP addresses for redundancy. I always include both primary and secondary on-premises DNS servers. The rule must be associated with the VPC to take effect. The rule must associate with VPC to take effect. You can associate the same rule with multiple VPCs or share rules across accounts using Resource Access Manager. Pro tip, use descriptive names for rules. Corporate domain forwarding, for example, is much better than Rule 1 when you're troubleshooting at 2 a.m. Creating a rule isn't enough. You must associate it with a VPC for it to take effect. Each VPC can have different resolver rules associated with it. This flexibility allows you to implement different DNS forwarding strategies per environment or application. Rule associations can be shared across AWS accounts using Resource Access Manager. This is perfect for multi-account strategies where you want centralized DNS management. Always test resolver rules after creation. Use NSLOOKUP or dig command from an EC2 instance to verify that forwarding works correctly before deploying applications that depend on it. Monitor resolver rule metrics using CloudWatch. High query counts or error rates can indicate configuration problems or capacity issues. Security is paramount. DNS security provides cryptographic validation of DNS records, preventing cache poisoning and man-in-the-middle attacks. Enabling DNSSEC is simple with Route 53, just one command. But remember, you must configure DNS records with your parent zone or domain registrar for the chain trust to work. Query logging is invaluable for troubleshooting and security monitoring. Every DNS query to your hosted domain gets logged to CloudWatch logs with details information. I use query logs to identify unusual traffic patterns that might indicate DNS attacks or misconfiguration. The logs includes the client IP, query type, response code, and even the edge location that will serve the request. Be aware that query logging can generate significant log volume for high traffic domains. Factor this into your CloudWatch logs costs. Here is enable the DNS security on the zone. This is the one-liner. And then configure query logging. This is basically CloudWatch logs where you enable on your account, you enable the log log group Route 53 queries, so you send those, and here you can access the AWS metrics from the logs from CloudWatch. Route 53 isn't just DNS hosting, it's also domain registrar. This command register a new domain directly through AWS, which simplifies management significantly. The contact information is crucial. Many top-level domain registries have strict requirements and will suspend domains with invalid contact details. I always use real monitored email addresses. Privacy protection hides your contact information from Whois lookups. For business domains, this prevents spam and protects personal information. I always enable it unless regulatory requirements prohibit it. Auto renewal prevents accidental domain expiration. One of the most embarrassing ways to take down a website. The domain will automatically renew before expiration. Remember, domain registration changes aren't instant. The process can take minutes to hours depending on the top level domain. Plan accordingly for time-sensitive launches. This diagram shows Route 53 most powerful features. Hierarchical traffic policies. You can combine multiple routing strategies in a single visual configuration. Start with geolocation to route users to the regional infrastructure. Then within each region, use weighted routing for A/B testing. Add failover for high availability. Here we have North America 70/30, Europe goes to Ireland. The visual policy editor makes complex configuration manageable. Instead of creating dozens of individual DNS records, you define the logic ones and apply it to multiple domains. Traffic policies are versioned, so you can safely test changes and roll back if needed. This is crucial for production environment where DNS changes can affect thousands of users. I use traffic policies for global SaaS applications where we need geographical compliance, performance optimization, and high availability all in one solution. Understanding Route 53 costs is crucial for budget planning. The pricing model is straightforward but can add up quickly. Hosted zones cost 50 cents per month. For most organizations, this is negligible. DNS queries cost 40 cents per million for the first billion queries monthly. This is where costs can escalate for popular websites. Health checks are 50 cents per month. With complex routing policies, you might need dozens of health checks. Factor this into the architectural decision. Resolver endpoint are the most expensive at 12 cents per hour. This is about $90 per month per endpoint. Design your hybrid architecture carefully to minimize endpoints while maintaining high availability. Optimization strategies include increased TTL to reduce query volume, consolidating health checks where possible, and using alias records instead of CNAME records to avoid additional DNS lookup. And traffic policy is 50 cents. It's $50 per policy record. $50 one policy used for complex scenarios. Congratulations, you've completed just a comprehensive journey through AWS DNS and domain management. Let me leave you with the key insights. Route 53 is more than just DNS, it's a global traffic management platform. The combination of health checks, routing policies, and resolver services can solve complex architectural challenges elegantly. Security should be built in from start, enable DNS security, use private hosted zones for internal services, and monitor query logs for anomalies. DNS is often overlooked in security assessment, but it's a critical attack vector. Cost optimization requires understanding your traffic pattern. Start with higher TTL values and optimize based on actual usage. Alias records are free and often perform better than CNAME. For certification exam, remember the key differentiators. Route 53's global alias record are AWS specific and free health checks enable advanced routing, and resolver endpoints enable hybrid architecture. Most importantly, practice these configurations in your own AWS account. The concepts we've covered today from the foundation of scalable, reliable, and secure cloud architecture. Master them and you'll be ready for whatever DNS challenges await you.